We still studying the sedimentary rocks, and we started last time the classification of sedimentary rocks according to their grain size, and we have studied the clastic sedimentary rocks. We will continue the rest of the part of clastic sedimentary rocks, and then we will go further to chemical sedimentary rocks. So for the clastic sedimentary rocks, there's a good table that can give you an idea about the grain size of each type of clastic sedimentary rocks, starting from boulders, cobble, pebbles, granules, coarse grained sand, coarse sand, medium sand, fine sand, till you go down to clay. And you will see on the left column the size in millimeter for each type, or for each type of the clastic sedimentary rocks in millimeters. And on the right two columns you will see the sediment, so from like more than 256 millimeter up to 2 millimeters. We call them gravel, and representative rock of this sedimentary rock is a rock called conglomerate. Then you have the other category, started from 2 millimeters down to 1/16 millimeter, which is the type of sand, starting from very coarse grained sand till you get to very fine grained sand. And this category of sediments we call it sand, and the representative rock of that is called sandstone. Same idea for siltstone. You start from 1/16 millimeter coarse silt, and you go down till you reach clay, which is smaller than 1/256 millimeter. And the sediment here is called mud, and representative of this sedimentary rock is called mudstone. And this classification is after Odin Wentworth grain size scale for for classifying sediments. So this table is a good guide for you to learn about grain size classification of clastic sedimentary rocks. As you see from this picture, this is a real photo for boulders, cobbles, and then you go to pebbles, and you see the difference in size. And boulder is a big and difficult to lift. I mean, you cannot carry it, and no upper limit to the size of boulder. Cobble will fit in one hand, or the large one you can carry it in two hands. Okay. Pebble is something that you could throw easily. You could hand it and throw it away. Okay. Smaller ones we call them granules, in gravel size. When it comes to smaller size of sand, ranges from 2 millimeters, as we said before. You can see the picture on the right: sand, silt, and clay. And silt is essentially too small for individual to be visible. I mean, you cannot see it easily. Clay is so fine that it feels smooth even if in your mouth. Okay, let's move on. Now this is the second type of our sedimentary rocks, which we call it chemical sedimentary rocks. And as we have seen before, the clastic rocks are dominated by components that were transported as solid, like clay, silt, sand, etc. So how about chemical? Is there a similarity? Yes. Chemical rocks also are dominated by components that were transported as ions in solution, not as a solid class. as ions like sodium ions, calcium ions, carbonates, etc. Okay, so almost all clastic rocks contain cement formed from dissolved ions. And many chemical sedimentary rocks include some clasts. What does this mean? It means there is an overlap between these two types, the chemical sedimentary rocks and the clastic sedimentary rocks. So since ions can stay in solution for years and can travel also for thousands of kilometers, it's not easy for us to trace their source rock. Okay? Good example of chemical sedimentary rocks is limestone, which is very famous rock. Other rocks include chert, banded iron formation, and evaporites. We will not talk in detail about every type of those, but we will take an example of limestone, chert, and maybe evaporites. Okay, you can see on the right side, you can see the picture of limestone and chert. Maybe you will be familiar with those when you see them in nature. Biological processes are important in formation of some chemical sediments. Yes, sometimes chemical sedimentary rocks, they have also biological processes. Limestone is composed of fragments of marine organisms that manufacture the calcite, and we know, all of us, we know calcite is a mineral for their shells. Again, most shells also include some of silica shells, also in their shells, tiny marine organisms such as diatoms. Next. Okay, so the limestone, almost all limestone forms in oceans, of course, in salty water. And most of them forms on a shallow continental shelves. But keep in mind most of them, because some of them also they form in deep areas. You see on the right side, you see the picture of reefs are highly populated by a wide range of organisms. They use the calcium and bicarbonate ions in a salty water, in seawater. Why they use it? To make carbonate minerals. The famous one of carbonate minerals is calcite. They do that, or they make those minerals for their shells. This is a picture of dolomite. So dolomite is just calcium magnesium carbonate, which is another carbonate mineral. Keep in mind, sometimes dolomite we call it, this name is called also for rock, not only mineral, it's also the name of rock composed of mineral dolomite. That's why sometimes scientists they differentiate between those two, and they call the rock dolostone and the mineral dolomite. But still, some other scientists they call the rock dolomite too. All of the dolomite found in ancient rocks has been formed through magnesium replacing some of calcium in the calcite. So the magnesium replaced the calcium in calcite carbonate, in carbonate muds and sands. And this process of replacement here to create the dolomite is called dolomitization. Dolomitization. Another example of chemical sedimentary rock is evaporites. We have also some examples of evaporites like halite and gypsum. They are composed of minerals precipitated from evaporating seawater or salty water like lakes. Not only halite and gypsum, but also borates, potassium salts, and magnesium salts. And every time the water becomes increasingly concentrated with dissolved salts, some of those salts start to crystallize. You see the picture of gypsum on the right side, and gypsum, of course, is calcium sulfates with water. It precipitates at about 20% of the original volume of halite, and of the original volume, and halite precipitates at 10% only. Okay. This is enough for today, and next lecture, inshallah, we will continue with the organic sedimentary rocks. Thank you and have a nice day.